sympathetic to all of your feelings and emotions, but I'm also hip to the jive that I want you to be as prepared for this AP test as possible, right? And there's just a couple more things I would like you to be familiar with, plus the practice that I want you to be able to do, right? So I will let your other non-AP teachers kind of feel the, oh, it's a half day, let's do something irrelevant and fun moment. And I would like to do something relevant and not quite as fun. All right? I know. I'm no fun. I've been here my entire life.
No fun, just cry.
I mean, he plays chess, so that's pretty hard.
So, at the end of yesterday, so as we noticed yesterday, if you take this disc and you roll it down the ramp, when it gets to the bottom, two things are happening. One, it's moving in the forward direction. True. But the other thing is it is rotating, correct? So what I would like to do is I would like to be able to write a statement that describes the linear velocity in terms of the height. Now, you'll notice the way that I drew the height here, I didn't draw it all the way to the ground because I'm drawing it from the center of the mass of the disk to the center mass of the disk, because that's how far the disk. I could go from the bottom of the disk to the bottom, or the top of the top, and it's center to center. Does that make some sense?
Yeah.
All right, tell me what kind of problem this is.
Energy.
It's absolutely an energy problem, right? It's absolutely an energy problem. So what am I going to start with then?
EI equals EF.
Perfect.
EI equals EF.
Right? The initial energy has to equal the final energy. What kind of energy do I have at the start? All gravitational potential. What kind of kinetic energy, what kind of energy do I have at the end? Kinetic. But is it moving forward? It is. But is it also spinning? So we actually have two kinds of kinetic energy. Right? We have the linear kinetic energy, which we call translational kinetic energy. All right, I'm going to write that down for you. So the linear type is called translational. Okay? The linear type is called translational kinetic energy. Okay? And we also have then rotational kinetic energy. So when I write this, I'm going to write that I have both translational kinetic energy plus rotational kinetic energy. How does that seem? Is that cool? All right, so let's then substitute in their appropriate equations. What's the equation for gravitational potential energy? What's the equation for translational kinetic energy? I like the murmuring. I like the murmuring. It's 1/2 mv squared. Now, yesterday we were making these comparisons between the linear versions and the rotational versions, right? So what do you think the equation is for rotational kinetic energy? 1/2 I omega squared. Fantastic. What is our object? It's a disk, right? So the rotational inertia for a disk is equal to 1/2 m
There's like a company that's something.
r squared. Okay?
That buzzing is so bad.
What's that?
That buzzing is so bad.
You have, Finn, can you close the door?
Last night. No, in the school bathroom. Yeah.
Also, if you watch something roll, okay, if you watch something roll, is it moving?
Yes.
Yes, it has some velocity, true, but is it also moving this way?
Yeah, which is.
So it has some both angular velocity and linear velocity or translational velocity, true? Well, we have a relationship between those three things. So if you, or those two things. So if you're watching an object roll, it's going this way and going this way. The center of mass of the object has speed v. Is that cool? The object itself has radius r, and it has angular velocity omega. Is there a relationship between these three variables? There is, right? We got it yesterday. It's probably, hopefully, somewhere in your notes. It says that v is equal to omega r. Correct? Now, if I rearrange this to solve for omega, what do I end up with?
R over V. Something like that, V over R.
Whether it's a capital R or a lowercase r, it doesn't really matter in this moment because it's just the radius of the thing. So it depends on how you call it. If I called this a lowercase r, it wouldn't matter. Is that cool? So, do I know the moment of it used to be called the moment of inertia, now it's called the rotational inertia. Do I know the rotational inertia of the disk? I do. Can I substitute in over there? Do I have an expression for the omega value? I do. Can I substitute in over there? So take a moment and plug and chug those two substitutions, all right, and then we'll see what we got. All right? Do that, write me out. I have to take attendance. And I gotta figure out what time this class is over, so I'll figure out why my mouse isn't working.
So,
There's no M.
I actually think the result of this is really interesting. So I have those first two terms, and now I'm going to plug in for these second two terms, and you tell me, so I is 1/2 mr squared, and omega is v over r, but this whole thing is squared. Now, what I like about this is if you look at the terms now, what do you notice about this second term and this whole last term? They're like terms now. How interesting is this? You're like, it's not that interesting, Dad. I promise it is. So on the left side, I have mgh. On the right side, I have 1/2 mv squared plus what? 1/4 mv squared. What happened to the r's? They magically disappeared, right? Because you have r squared over r squared. How awesome is that? So tell me, I can combine these two on the right. What's a half plus a quarter? 3/4, right? Does each term also have an m? Can I make those disappear?
Yeah.
So I end up with, on this side, GH is equal to 3/4 v squared. So v squared,
Are we solving for height or for velocity?
it's the velocity in terms of the height.
It's like everything.
Anybody get that besides me?
Would the unit on this still be meters per second?
Totally. Now, here's the thing I think is really cool. Okay. Here's the thing I think is really cool. In order to get this to roll, you have to have some minimum amount of friction. Because if I just put this on here and there was no friction, what would happen to the disc? It would just slide down. True? So what friction does is it provides enough force to get it to roll. But let's take a step back and let's calculate this as if there were no friction at all and it just slid down. If it just slid down,
Rotational?
it would have no rotational energy because if it just slid down, it'd just be moving down, right? So you'd end up with mgh is equal to 1/2 mv squared, and v squared would be equal to 2gh, and v would be equal to the square root of 2gh. But what do we have here? We have it rolling. So what do we notice about its linear speed if it just slid down versus its linear speed if it rolled down? Which of those is larger? If it slides down, it's the square root of 2gh. That's bigger than the square root of 4/3, true? So what this means is some of the energy, when it rolled down, went into getting it to spin. And here, because there's no spinning, it would actually be moving faster. Who's that? Is that you? You're good. So this is how, okay, this is how we use the energy for an object that's rolling. We have to consider both the translational kinetic energy and the rotational kinetic energy. Does that sound good? All right, can you get out that 2019B that I handed you yesterday? 2019B and then boy.
But I totally did. It's in bold. They. It's a whole list, right? I actually tried.
Should I go?
A lot of them.
This one confused me because I thought I was supposed to prove that or something, and I put the numbers. So what did you say?
Yes, show that.
Yeah, I was not reading.
It happens.
Read me. Read me. Don't read. Like, these Oh, are they on that?
It should be.
You also have a 2005 number 2. You also have that one?
Maybe I left it there. Oh, just any of the equations, like the S, the G,
Yeah, like you G negative G, M1, M2 over R.
I don't know what ones.
Seasonal allergies killing you, man.
Is something 3. I know that it'll end with a C. That's what I know.
FC. Say what FC is equal to.
So it'll tell you that the centripetal acceleration is equal to v squared over r. That's 4. mv squared over r. Okay? And then you get that.
I was trying to see if I had to memorize them.
You don't?
How do you speak?
That's,
Yeah, should I go donate
Do
blood?
we have any robot competition cards?
They have a cool Snoopy shirt. I kind of want to
Is
wear
that all you guys do?
Put up a petite
it.
one.
It's $20.
That's at 8:30,
I'm not old enough to donate that.
I got like half the points on one of them that I did,
I'm not 18 yet.
but that's not what I don't know.
I didn't know.
Wait, what are
No, I can have any blood type. I found out the other day. I can be any blood type,
And then I have to do
A on
these, because I need to learn them, and then I need to do some of like what Mr. Smith was
Like all my
talking about.
siblings belong in this
So now I have to write a stupid list, but I don't have a sticky note on me right now.
I don't have one.
Why were you like,
So if I need a
why
kitty,
do you have a sticky note on your shirt?
I don't know, so I was just looking at something.
I know, right?
All
What
right.
else will I get out of you?
So, if you look at the key for 2019 that I just handed you, okay, the first question is actually a question that you guys have done before, true? Like, create an expression for the minimum speed, true? Right? That is a question you've done before. The second one says, write an equation of h in terms of b or something like that, yes? And so what you have to do is you have to start with the energy, but you're going to need to consider both the rotational and, okay, you need to consider both the rotational energy and the translational kinetic energy. Is that cool? Now, one of the things about the back, okay, one of the things about the back that I want you to keep in mind is you're going to get a line that somehow looks like this. You need to draw a straight line. You obviously are going to need to calculate the slope and the intercept, true? And you're going to write it in terms of y equals mx plus b, correct? So in the thing, it says write the h in terms of the b. So on your y-axis is h, you need something for the slope times the b value, and this is plus something for the intercept. You with me on that? So when you go to calculate, when you go to write the equation, you need to know what is this thing and what is this thing, and you're going to get them from here. Okay? So you're going to use the equation in the second part, in part B, to inform your understanding, so after you draw the graph, you can do part D.
Okay.
Is that cool? Okay. Is this over at 13?
Yeah.
All right. I feel like that was good use of our time.
Yeah, it was good.
So listen, before you start packing up, I want to tell you a couple things.